Getting there.
Right. So earlier today, I sent out some partial solutions to the last homework where I just gave you some random integrals. But let me start out by saying, oh, first of all, let me get rid of this stuff. This is not calculus over here. This is the class I just finished.
I didn't want to be the one to ask, but I was like, what is that? What did I miss?
No, you didn't know. That was real math that we were doing earlier.
You had me really low.
So anybody have any questions about the previous homework or any homework before that? Get rolling. Anybody have anything they want to know?
Like including the homework from yesterday or no?
So I couldn't quite hear you, Michaela. What?
Wait, can we ask questions about our last homework or no?
Oh, you can ask questions about anything.
Okay, I had a question about number 4.
So wait a minute. So which homework?
Like the last homework.
The chapter 8 guides?
Yes.
So number 4, which I conveniently didn't number any of them.
Oh yeah, sorry. It was the integral of e to the 4x. That
Oh,
one.
yeah, sure. So I did send out some partial solutions, but I'll go through this. Yeah, I don't know why I didn't label them, but you know, whatever. Oh, hold on. I gotta let somebody in. Hang on a minute here, and there we go. Okay. So integral of e to the 4x square root of 1 minus e to the 2x dx. Okay. So that looks pretty awful, right? So the first thing I'm going to do is break this up because we got e to the 2x. So I'm going to do e to the 2x, e to the 2x, square root of 1 minus e to the 2x dx. So I split e to the 4x in 2. So this problem is now a u substitution problem. So we're going to let u equal 1 minus e to the 2x. All right. And then du, well, the derivative of u is du. So the derivative of 1 is 0. And this derivative over here is negative 2 e to the 2x dx. Now, there is no negative 2 anywhere in this problem over here. So this negative 2 has to be removed from this side over to here. Okay, so now we're down to there. And, hang on, oh, here we go. All right, so e to the 2x dx. There's e to the 2x dx right there. I hope you can see these colors okay. So now our integral looks like this. Here's the negative 1/2, and here's the du. So these two pieces are right here. 1 minus e to the 2x u. That gives us the square root of u. So this comes down here. But now we have this extra e to the 2x over here. So what I'm going to do is rearrange this piece over here. I'm going to subtract it over, and we get 1 minus u is equal to e to the 2x.
I see. I think I got up to there.
And this, oh, you got up to this part?
No, I didn't think to like change the u.
Oh, yeah, that's kind of like a u sub, right?
Yeah.
So this e to the 2x is now this. So we have 1 minus u. And I hope you can see that okay. So we okay so far?
Yes.
Yeah, and now we're good, right?
Yeah.
Yeah, so this is the hard part of calculus 2. So when you're in the homework section, it says like trig sub, you know to do trig sub. If it says u sub, you know to do u sub. So I sent you a bunch of integrals and you have to figure out what to do. So all of this becomes this. Now, u to the square root of u is u to the 1/2. So I'm going to multiply it through. We get negative 1/2 integral u to the 1/2 times 1 is u to the 1/2. And then u to the 1/2 times u gives me minus u to the 3/2. All of that. I'm just going to pause there for a second. See if there's any questions. Right. And by the way, I'm recording all of this, so if you're having trouble reading it or something, you'll have it for later. So now for this integral du, we just do the basic power rule. So coming up here, so we get negative 1/2. So u to the 1/2, add 1 to the exponent, that's u to the 3/2. Divide by the new exponent, that's 2/3. And then we have u to the 3/2, add 1 to the exponent, that gives me u to the 5/2. Divide by the new exponent, that's 2/5. Whoops. 2/5. Running out of room here. Plus c. So that answer that I have right there is correct. So Michaela, you okay so far?
Yes.
Okay, so that answer is correct, but we're going to replace all of the u's by this, because that's the proper way to give it back. So what we have is, so we get 2/3, 1 minus e to the 2x to the 3/2 power, minus 2/5, 1 minus e to the 2x to the 5/2 power, plus c. And that's the final answer. Yeah, so that one was a little bit messy. And doing the derivative of this would be a good thing for you to do. The derivative's not so bad. So you should probably, probably try that. So the solution sheet I sent out a few hours ago, all of those 12 problems from that homework sheet, I've gotten you started on all of them. So take a look at those. And that's good. So what else we got? Anything else from there? All right. So we have 3 more sections to do in this chapter. We're going to start one of them tonight, and I'm not going to get all the way through it tonight because I'm going to go slow because I know this is confusing. So tonight and Thursday, we'll do the partial fraction decomposition, and then we have 2 sections after that. So after the partial fraction stuff, the last 2 sections aren't new methods of integration, but it's something that comes up in integration that doesn't require a new method, but a new sort of philosophical perspective, something called improper integrals, where we don't go from A to B, we go to infinity. So we'll pick that up next week on here. Okay, so here we go. A little bit of background first. Whoops. Can't spell. So the fundamental theorem of algebra. All right. So this technique we're starting tonight is called partial fraction decomposition. Did a little example last time. 95% of all of these problems are just straight algebra. The integration is just a little thing you do at the end. So the fundamental theorem of algebra says this. Every polynomial can be factored into linear and or irreducible quadratic factors. Well, that's a whole lot of words right there. So every polynomial can be factored into linear and or combination of irreducible quadratic factors. Now, all the way from early high school, whenever you started algebra, factoring is a big part of algebra, right? Factoring trinomials, factoring the difference of two squares, factoring numbers into prime factors. This comes up a lot. And you practice all those techniques for a while. So let me give you an example of what these are. A linear factor. A linear factor looks like this: x plus or minus some constant c. What makes this linear is the exponent on the x. What's the exponent on that x? There's nothing there. So what's the exponent?
1.
1. And that's linear. An equation that has an x to the first is just a straight line. That's why it's called linear. And this is plus or minus just a constant. So x plus 2, x minus 5, x plus 0. Irreducible quadratic. An irreducible quadratic factor looks like this. X squared, that's quadratic, looks like a parabola, and then plus some constant c. And c has to be bigger than 0. So an irreducible quadratic like x squared plus 1, x squared plus 5, x squared plus 7. And what we mean here by irreducible, let me put this down here a second. Close this. Well, here's a reducible. So x squared minus 25, that factors or reduces to x plus 5 times x minus 5. That factored into two different linear factors. That's reducible. Irreducible is something like x squared plus 49. That looks like it might factor, but it doesn't because of this. Now, when I say irreducible, I mean in our class. This actually can be factored. Anybody know how that can be factored? Factors into something with imaginary numbers. Well, imaginary numbers is the wrong word, by the way. Complex numbers. Anybody know how that can factor? Just curious. It's okay if you don't know.
Plus or minus 7i.
Yeah, nice, John. So we have these complex numbers where I is equal to the square root of -1. Probably the only time you've seen these is in a pre-calculus class. So this can reduce into x plus 7i times x minus 7i. So I times I is equal to -1. So they do reduce, but not in our class. In Calc 1, in Calc 2, and Calc 3, you won't see complex numbers at all. They don't come up. For those of you going into differential equations eventually, that's the next time you're going to see the imaginary numbers on here. So for us, that doesn't reduce. So the fundamental theorem of algebra, every polynomial can be broken down into either linear or irreducible quadratics or a combination of both. All right, so that's what we're going to be working on. So put that away for right now. So let's do sort of an example here. So we have the integral of, let's say, x over x plus 1 times x minus 4 dx. Now, in the denominator, so it's all about the denominators here, we have two distinct linear factors. Okay, well, 2 obviously means 2, and factors means multiply. So these are linear because the exponent on the x's is a 1. That makes them linear. What does the word distinct mean? That has a meaning in mathematics. What does distinct mean? Well, in real life, it means the same thing. Anybody know what the word distinct means?
Like separate?
I'm sorry, did you say separate?
Yes.
Kind of close. They're different. So separate, yeah. So they're different. This is x plus 1. This is x minus 4. So they're different. So this is going to break down into this. We can break this down into the integral of a over x plus 1 plus b over x minus 4 dx. And a and b are constants. A and b are just numbers, 5, 3, -2, or 1, or something like that. And here's why we can break this down. So let me take you back to grade school for a little while with fractions, because we all hate fractions, right? It's the F word of math. So if we have 5 over 7 plus 3 over 5. This is really basic here. How do we add those fractions together? The answer is not 8 over 12, right? What do we have to do first?
Find at least common denominator.
Yep, find the I prefer the word laziest here, laziest common denominator. And that is 7 times 5 is equal to 35. Okay, so to get 35, we multiply this by 5, we get 35. Multiply this by 5, we get 25. Multiply this by 7, we get 35. Multiply this by 7, we get 21. And our final answer is 46 over 35. Okay? So partial means parts. So this was partial fraction composition when we go that way. When we break this down, we can see that 46 is equal to 35 is 7 times 5. So we know this fraction breaks down into two fractions like this with numbers on top. Our job in this section is to figure out what these numbers are. So that's the basic behind what we're happening. Because that's what we have here. Now, a and b are just numbers. And once we pick a value for x, those denominators are just numbers. So if we wanted to add these two fractions together, the LCD, the least common denominator of these two fractions, is this. So we have two parts here and we're breaking it down. Now, okay. Now these are both linear factors on the bottom. So the answer here is going to be a times the ln of x plus 1 plus b times the ln of x minus 4, yeah, plus c. So let's see where I got this from. I'm going back to the other board now. And I am, just a reminder, I'm recording all this, so you'll be able to keep watching on here. the integral of 1 over x dx. What's the integral of 1 over x? The integral of 1 over x.
Natural log of x.
Yep, it's the ln of x plus c. But it turns out, if we do the integral of 1 over x plus or minus a constant, it's the same thing. That plus or minus constant doesn't affect it because the x is linear. So the integral of 1 over x plus or minus a number is just the ln of x plus or minus that number. So that comes up nicely because a and b have to be just numbers, and I'll explain that when our next class on Thursday. So our job now is to figure out what the a and the b are, and then this problem is done. So let me pause right there because my throat. Questions about anything yet? Okay. All right, so here's how we're going to do this. Back to my other board here. I think I don't have enough whiteboards. So we have this. We have x over x plus 1, x minus 4. And I'm claiming that that's equal to a over x plus 1 plus b over x minus 4. And we always start out with a plus sign here. It may turn out that that's negative later, but that will take care of itself. Now, forget the fact that this is an integral, and forget the fact that we're in calculus. Just algebra here. We've established an algebraic relationship from the left side to the right side. So whatever I do to this side, if I do it exactly the same to this side, it stays equal. So what I'm going to do is multiply everything by the LCD. Going to multiply all the way across, distribute it all the way. Oops, sorry. Whoop. Hang on, somebody dropped out and came back in. Hang on just a second. The last day or two, I know some people have had trouble maintaining the connections on the meeting here. They drop out and come back in. Yakov, are you here?
Yeah, sorry, I just had to switch from my laptop.
Oh, okay. I just thought you lost connection. That's been happening a bunch today in my other classes. People drop out, come back in, drop out, come back in. Okay.
No, thanks.
When we multiply across, so when we multiply here, the x minus 4s cancel out, and that leaves us with b times x plus 1. That marker's no good. When we multiply the LCD against this term, the x plus 1s cancel out, and that leaves us with a times x minus 4. When we multiply the LCD over here to this term, they all cancel out, and we're just left with an x. Okay, everybody all right? Okay, now, forget this part. We're done with that. We have one equation, and we have two unknowns. So I'm going to do the shortcut method on this one. So the shortcut method is we're going to let x, we can pick anything we want for x. So I'm going to let x equal 4. And replace all the x's by 4. So we get 4 is equal to a times 4 minus 4 plus b times 4 plus 1. And the reason I did that is because the a is now going to disappear. So this says that 4 is equal to 5b. Because that's 0. And this says that now 4 over 5 is equal to B. So we found our value for B. So this is what I'm going to call the shortcut method. We can't always use this, but tonight we will. All right. Okay, so now I know what B is, 4/5. Now I have to figure out what A is. So I'm going to pick an X value that makes B disappear, and that X value will be -1. So if we let X equal -1, we replace all the X's by -1, including this one. Then we get A times -1 minus 4 plus B times -1 plus 1. And that says that -1 is equal to -5A, and that means that A is equal to 1/5. And now we've completed this problem. All right, questions yet? Okay, so now we know what those two things are. So back to our problem. So A was 1/5, and B, oh, I forgot what B was. 4/5? I forgot, I erased it. Was B?
Yes, it was 4/5.
Thank you. And there's the answer to our problem. That's done. So like I said, partial fraction decomposition integrals are 95% algebra. And if some of you I know have seen this in like pre-calc, and it's not that bad when you do a few, but if this is the first time you're seeing this, this probably seems kind of overwhelming, but I'm going to go a little bit slow here. And that derivative is pretty easy to do. So you should definitely do derivatives of your answer, and you will get back here. Okay, let's do another example. Let's do the integral. Now, a lot of the homework problems, the denominator is already factored, but not always. So let's do x plus 1 over x plus 3 squared dx. Now, there's no other method that U substitution, trig sub, all that's not going to work. So here now we have, so x plus 3 squared is x plus 3 times x plus 3, and we have 2 repeated linear factors. Last time we had 2 distinct linear factors. They were different. Now, both of these factors are the same. They are repeated. So we have to allow for every possibility. So when you have repeated factors, it's going to break up like this. We have A over x plus 3 plus B over x plus 3 squared dx. We have to allow for both cases. And let me go over to the other whiteboard for just a second to show you why this is happening. And then I'll come back to this one. What's the LCD in this case? Not a trick question, by the way. Right?
3.
Yeah. No, not 3. I thought I heard 3. What's the common?
9. I'm sorry, 9.
That's okay. I know what you.
Sorry.
That's right. It's late. It's dark. I get it. So it's 2 over 3 squared. Oh, so the common denominator here is 3 squared. So we change this one over here. We change this to 3 over 3 squared plus 2 over 3 squared, and our final answer is 5 over 3 squared. So in this direction, we did partial fraction composition. If we started with this fraction and went this way, we can see that our fraction breaks up into 2 different fractions over here. So that's what's happening. So if we have a thing like this, if we have a fraction like 7 over 25, we can see that I could break that fraction down into a over 5 plus b over 5 squared. The common denominator of these 2 fractions is 25. Our job is to figure out what the top numbers are. Now, in this case, it's possible that a could be 0 because I still have that composition here, but b can't be 0 because then I wouldn't have a 25. So that's what's happening when we have repeated linear factors. So back to our problem here. Okay. So here's where we are. We have to figure out what a and b are. So again, we have, so I'm going to take these away right now. Let's forget that we're doing calculus. Good thing I'm recording this, isn't it? And we're going to multiply everything by the LCD. The whole equation. Okay. These cancel out and just leave me with x plus 1. Over here, when we take this cancels out one of these and leaves me with a times x plus 3. And when we multiply the LCD to that term, they all cancel out and leave me with b. So I'm just going to pause there for a second. Take a moment just to take a breath and think and see, do you have any questions about anything yet? It's a little overwhelming, I know. I've been there. All right.
Wait, I'm sorry. How did you get b by itself?
So I'm multiplying by x plus 3, the quantity squared. And when,
So they cancel.
when it hits that term, yeah, they cancel out.
Gotcha. Okay.
Right.
Thank you.
Now, if this wasn't a 2 but a 3, I would have another term that said c over x plus 3 cubed. We're not getting crazy with it in here, but you can keep on going forever. So that was a good question. That was Kate, right?
Yes.
Okay, yeah, good question. I'll bet there's a lot of people happy you asked that, by the way. Okay, now, so if I let x equal -3, this term will disappear and I can figure out b. That's the shortcut method. But because b is all by itself, there's no x, I can't make b disappear because there's no x here. I can't pick an x that makes that go to 0. So what I'm going to do in this time is not do the shortcut. I'm going to multiply out. Like that. And here's how we're going to solve this. We're going to do something called we're going to do equate coefficients. It's like a little bit of a game here, a little bit, right? Now, because this is an algebraic relationship, that means you think of this as the equal sign, but you need to think of it as the word is, means this side is that side. So they have to match up. So if we look here, those two terms are constants because there's no x over here. This term here, that term has an x in it. So if we look back and forth on both sides, here's an x all by itself, and here's an x all by itself. In order for these to be equal, these coefficients have to be the same. This is a 1. That means this has to be a 1. Whole bunch of if-then logic thinking here. And that was for Cody, Brandon, and Nicole. So A is equal to 1. If there was a 3 here, this would have to be a 3. So we're just kind of visually going back and forth. Looking over here at the constants, here we have a +1. Since the two sides have to be identical, that all has to be +1. So we have 3a plus b must be 1. And I know what a is. A is 1. So if a is 1, 3 times 1 is 3. So 3 plus b is equal to 1. And that means that b is equal to -2. And I'm just going to pause there for a second. See if we got any questions. Okay. All right, so now up to here. Now, let's go back. And let's remember that we're doing calculus. Okay. So now A is 1. And B is -2. So here we have a negative. The negative came out here. So we can take away the positive sign, put a negative here, and put a 2 up here. Everybody okay? Kinda, sorta. All right, so now we have to do this integral. So here's our new integral right over here. Let me just rewrite it, make it look nicer. All right, so there's the integral we have to solve. Okay. This is just linear. It's x to the first. So this just becomes the ln of, so 1. If this was a 3, I'd put a 3 here, but it was a -2, I'd put it. So the ln of x plus 3 minus 2 times the integral of 1 over x plus 3 squared dx. So I did this integral, and then I just cut and paste this one down here. I took the constant out. And now we have to do that integral. So how do we do that integral? So that goes, this integral, so forget all this other stuff. We're just looking at this. That's a calculus 1 integral, the kind you learned at the end of Calc 1. How do we do that? It's x to the first. Here's a hint, starts with a u. This is a u sub integral. u is equal to x plus 3. du is equal to just dx. So what we get is the ln of x plus 3 minus 2 times the integral of 1 over u squared du. So from here, we ended up here. Any questions?
Should whatever is in the ln be an absolute value?
Yeah, these should be absolute value signs. You're right, Jordan. I'm a little sloppy with all of that.
All right.
Yeah, technically, it's because the ln, so yeah, I'm a little bit sloppy with that. And because we're not doing, our integrals aren't, at this point in time, our integrals aren't connected to any kind of like real world application right now. So if you have the integral, if you have the ln of something, I know, just call it, here, I'll just call it an ln of a star, right? This is called the argument of that. So when you have a sine of something, a cosine of something, an ln of something, these are called the arguments. And whatever's in here has to be greater than 0. You can't have, the ln of 0 is negative infinity, and the ln of a negative number does not exist. So this is a good question you brought up, Jordan. I'm kind of impressed you knew the little subtlety here. So let's do a little graph here. So we have y is equal to, oh, let me do this. If f of x is equal to e to the x, all right, e to the x looks like this. That's what e to the x looks like. Well, it's a little sharper than that, right? E to the x looks like that. You should all be familiar with that. So I'm going to put this line right down here. This is the line, y equals x. So x to the first linear, it's 45-degree angle right through the origin. If we have another function, g of x, and we call that ln of x, how are the two functions e to the x and ln of x related? What's the relationship between these two functions?
Inverse.
They are inverses of each other. That was Yakov, right? Yeah, nice.
Yep.
So functions and their inverses undo each other. Like the square root of x squared is equal to x, and the square root of x squared is equal to x. So they reflect over these lines. So the graph of ln, this is g of x. Well, it doesn't look like it on my picture, but. So the graph of e to the x and ln of x are mirror images on either side of that y equals x lines. They are inverses of each other. And this, the ln of x, the purple line here, never hits the y-axis. It just keeps going down to negative infinity. So here's x equals 1. So the ln of numbers bigger than 1 are positive. They're above the x-axis. Numbers smaller than 1 but positive, fractions, are below the x-axis, and they head down to negative infinity, and it never comes over here. So when Jordan said the ln should always have absolute value signs in front of it, he's absolutely correct. I just get kind of lazy with it. An excellent observation, Jordan. That was really good. Okay, so back to our problem here. Now, all this makes you wonder why anybody would ever be a math major, right? Okay, so here we go. Okay, so now our problem becomes this. Well, I'm going to rewrite this as u to the minus 2. And how do we do that integral? What's the integral of u to the minus 2? How do we do that? This is a Calc 1 problem, level. Well, basic power rule. So we add 1 to the exponent, so we get u to the negative 1. And then we divide by the new negative, which puts a negative here. We get plus c. That answer is correct. But we need to replace that u. So we get the ln x plus 3. Negative is positive. And I forgot what the u was in this problem. What was our u in this original problem? Completely forgot. Only 2 factors. You'd think I could remember. But
X plus 3.
thank you. You'd think I could remember something like that after 2 minutes, right? The ln of, oh, here you go, Jordan. Actual absolute value signs. X plus 3 plus c. And I'll replace these as well. When it comes time for the test, if you use parentheses instead of absolute value signs, I'm going to be okay with that. And this, now, that's the answer to that problem. That derivative is very easy to do, so you should do the derivatives of your answers. Well, that was a lot, wasn't it? Anybody got any questions? Probably stunned, I'm thinking. Okay, I'm just going to do one more example for tonight. So tonight we've done 2 things. We've had distinct linear factors in the denominator, meaning they're different. This was an example of repeated linear factors, which means the same factor over and over again. And so now I'm going to do just one more example. So when we come back here on Thursday, we're going to deal with irreducible quadratic factors, and that's all there is to partial fractions. So one more example here. I'm just going to make something up, which is probably a bad idea, but so let's see. So 5t, and let's do t minus 6 and t minus 1 dt. I switched to t's because I'm tired of x's. That's the only reason. Okay, so we have two linear factors, and they're different. They're distinct. So this integral can be broken up like this. First of all, the 5 is a constant. Just pull it out front. Don't forget it, but kind of ignore it for a while. So we get a over t minus 6 plus b over t minus 1, and then dt. A and b could both be negative, but that will all happen by itself later. Okay. So now we have this. So now I'm just going to write this down here. Let's do this over here. So we have t over t minus 6, t minus 1 equal to a over t minus 6 plus b over t minus 1. All right.
I have a question.
Yeah, go ahead, Kate.
Does it matter, like, as you wrote it just there, on the left side, it says t over t minus 6 and then whatever. It was originally 5t. Does it matter if the 5 is there or not?
No, it doesn't. Eventually it does. So constants just go along for the ride. So I threw it out in the front.
Oh, okay.
And then I'm just going to ignore it because what I'm doing over here on the second board, I'm just looking for A and B.
Okay.
Now, you could leave the 5t in there, and that would be mathematically correct. But then I have another number to deal with, which introduces the possibility of an arithmetic mistake somewhere along the line. So that kind of makes sense?
Yes.
Yeah. So in general, not even calculus, not even math, just life. If you have a problem to solve in front of you, math, science, chemistry, I don't know, romance or whatever, if you can simplify the problem before you start to solve it, it's easier to do and less chance of making a mistake. So I just put that number in there just as noise because that happens. So I threw it out. I'll put it back when I'm all done. But excellent question. Thank you for that.
So if it was like, instead of it being 5t, if it was like 5t plus 1.
Oh, that's different.
Okay.
Then you'd have, because if it was, oh, great question, by the way. If this was 5t minus 1, now I can't pull the 5 out of, well, I could, but I can't really factor that out, right?
Yeah.
Yeah, great question. Yeah, so this case, it's just a regular old constant, goes out and goes for the ride. That's
Okay.
That's a really good question. Wow. Okay, so now multiply everything by the LCD. So we'll get t is equal to a times t minus 1. Oh, geez, that's bad. T minus 1 plus b times t minus 6. So when I multiply everything by the LCD, this is what I'm going to be left with. Now in this problem, we can use a shortcut method. I can pick two different values of t, one to make the a disappear and one to make the b disappear. So if we let t equal 1.
So just a quick question. This is like a similar example to the first one we did?
Yeah, not the last one, the one before that, yes.
The first one, okay.
Yeah, so what you should start to recognize when you're doing the homework is kind of every problem is exactly the same. All that really changes are the numbers, if that makes sense. So partial fractions, your ending integral is either going to be the, if you have linear factors, you're going to get the ln of something. If you have a factor that's a linear factor squared, you're going to get a u substitution, 1 over u squared. And next time when we do the irreducible quadratics, x squared plus a number, our answers are going to involve an arctangent, like we did in the trig sub. So good observation, Yakov. So if t is equal to 1, here's a t, so there's a 1. If t is equal to 1, this is all 0. If t is equal to 1, we get negative 5b, and therefore negative 1/5 is equal to b. And there's our value for b. Now, to make the b disappear, we let t equal 6. So here's a t, so we put a 6 here. And then if we put a 6 here, we get 5a. We put a 6 here, this is 0. So a is equal to 6 over 5. And that's all we need to finish this problem. So here we go. You okay so far? Questions? Great questions tonight, everybody. Okay. And now, Kate, here I'm going to remember to put the 5 in. So we get equals 5 times. So our a value was 6 over 5. Our b value was negative 1 over 5. So I can change this to a negative sign and just put 1 over 5. Oh, anybody notice something about those two numbers? What do you notice about a and b? Positive?
They equal 1.
Yeah, if you put them together, they equal 1. I wonder if something's going on there. Yes, there is. Good observation. Okay, so now, so this is just t to the first, so we get 6 over 5 ln of t minus 6, absolute value signs for Jordan, negative 1 over 5 ln of absolute value of t minus 1, and then plus c. That answer is perfectly fine, but we can make it look a little better by multiplying through by the 5 here. So this gives us 6 ln t minus 6 minus ln of t minus 1 plus c. And there's the answer. The derivative of that is pretty easy to do. I highly recommend you do derivatives of your answers from this stuff. And there we have it. I think I've melted your brains enough for one night. What do you think? Total silence. So I'm right. All your brains are melted. All right. So that's good for tonight. On Thursday, we're going to do some problems with irreducible quadratics, and that involves possibly a U substitution and possibly an arctangent, which I'll review a little bit. So we're good for tonight. I did send out earlier today. Well, let me stop the recording here. I don't want to waste file space. I sent out a handout with getting you started on all of the integrals from the last homework I put out called Chapter 8 Guides. So next time we'll go over any homework you want and we'll go from there. So anybody got any questions about anything? All right. Lots of good questions tonight, Kate. Thank you very much. Those were good. Jordan, excellent observation on your part. And notice I put the absolute value signs here just for you. So that's it, folks. See you back here on Thursday. And just a reminder, check your emails before class. You're my third class for today, and there's been some issues with connectivity, getting into Zoom and the internet and all that kind of stuff. So check your emails to make sure that, class is happening. All right?
All right. Thank you. Have a good night.
All right. Thanks, everybody. Good night. See you on Thursday.